Alright guys, sorry about that. I'm not really sure how we got cut off, but something happened, and there's probably going to be a lot of technical glitches as we go, and I appreciate your patience. Alright, so this was the last example for the notes for today, and it'll be really fast. But the reason I wanted to do one more is because you're going to notice a lot of times when we do these problems that you're going to have overlapping triangles, like is the case in this specific problem. Alright, so when we read the statement, it says that triangle ABE is similar to triangle ACD. So ABE and ACD there. Alright, so before we solve for the missing variables, I think it's going to be really helpful if we draw these triangles separately. So I'm going to give that a shot here. Alright, so here we go. We got, well, that's terrible. Let me try that again. Alright, we've got triangle. Not much better, man, that's bad. Alright, A, B, E, and it's similar to the bigger one. Triangle A, C, D. Alright, now I'm going to label everything. Now because I drew these correspondingly and I know that this side corresponds with this side and this side with this side, I'm not going to put the little dots on there because I can visually see what matches up, but you can if you like. So I know that AB is 4. I know that AE is Y. I know that BE is 8. Right? And I know this is Z degrees. Right? In the bigger triangle, I know that from A to C is this plus this, so it's X plus 4. And I know from A to D is Y plus 5. And then I know the bottom CD there is 12. So you guys will notice that by drawing them separately, it's easier for me to see that this entire length is X plus 4 and Y plus 5. All right, now to solve for the similarity ratio. So again, first step, which parts match up that are both numbers, right? So I can see that BE and CD correspond to each other in my similarity statement. They both have numbers, so that's going to give me my similarity ratio. And it doesn't say which direction to go, so I can pick. And I'm going to go from this way to this way, from ABE to ACD. And that's going to be 8 to 12. And that simplifies. You divide them both by 4, right? You get 2/3. All right, so now to solve for x. So here's what I know. I know that the similarity ratio is 2 to 3. All right, and let's see what corresponds with what. What has x in it? X plus 4 is this side, so that corresponds to this one. I'm going to go in the same direction. So I said the similarity ratio is 2 to 3, so I'm going to say that equals 4 over x plus 4. And then I'll solve by cross multiplying. And just like we did yesterday, be very careful that you distribute when we cross multiply this too. So 2 times x plus 4 is going to give me 2x plus 8. And 3 times 4 is going to give me 12. Subtract 8 from both sides, so 2x is equal to 4. And then I'll divide both sides by 2, so x is 2. So I know x is 2. All right, for y, I want to find sides that correspond, that have y's in them. And I notice that I've got here and here. So to set it up, again, from left to right, the similarity ratio is 2 to 3. So I'll say 2 over 3 is equal to y over y plus 5. And just like that previous example, when I cross multiply, I'm going to distribute. So I'll get 2y plus 10 is equal to 3y. We'll subtract 2y from both sides, so 10 will be y. And then last but not least, you guys, z. Z is the easiest one. And hang tight for me just one second. Z is the easiest one here. And it's just if angle E corresponds with angle D, and angle D was 50 degrees, then angle E must also be 50 degrees, so Z will be 50. Alright guys, that's it. Sorry I couldn't put this all in one video. Anyway, have a great day.